And whiteboard. I'm mainly concerned with whether you can tell me. Check, make sure I got the right. Nope. Should do that. Yeah. With 4.1 and 4.2, I want you to make sure that one, you know what the positive, negative, and no correlations. I want you to be able to work that out. In other words, look at a graph and put a line with that graph and tell me whether it's positive, negative, or no correlation. And then I want you to be able to find the slope of a line once you find it. That's the only two things that I would even test you on. I'm not going to ask you for the correlation coefficient because that's just too much work. Unless you got a TI-84, which spits it out. Okay? So that's the only two things I'm going to ask you on the 4.1 and 4.2. So let's move on to 5.1 and 5.2 because that's where most of your test is going to come from, is chapter 5. So while I'm doing that, I'll also pull up the probability, the addition, multiplication, and counting. So I'm going to go through these sections, 5.1, 5.2, 5.3, and 5.5. So that means 5.4 and 5.6 you don't need to do. I'll go to my handy dandy. Y'all remember what I just said? Or I forget. I said 5.4, right? So unassigned 5.4 and unassigned 5.6. So what does that mean if I unassign it? You don't have to do it because somebody's going to ask me that. Do we have to do it? Let's go ahead and pull it up. Let's see, chapter 5.5. Check that one out. And 5.4. And 5.6. So that means we got to add 6 points. Check it on easy homework. 1, 2, 3, 4, 5, 6.
You just took a 10.1 and turned it to 4.
Where?
It was the last one you did.
All these stupid quizzes. I don't even count them. Okay, this one needs to be 4. Quizzes. Can't get rid of them. Let me check them. Homework. 100. There we go. And the test should be 102. Yep. Okay. So that's fixed. So 80% of your test is going to come from, well, probably 90% of your test is going to come from 5.1, 5.2, 5.3, and 5.5. So we've already started it, and we'll go ahead and remind you. I'll remind you what those sections were on. 4.1 we've already. 5.1 we've already started. I'll put a couple of questions up there. Your basic rules of probability, and the basic rule is basically the probability of an event happening is equal to the number of times something actually happens over the number of times what? Tried. Oops. Okay, the number of times tried. Now that's that's both with the Mayberry probability and the physical probability. Now, what the heck is the Mayberry probability and the physical probability? Well, the Mayberry probability is the mathematical probability, meaning that that's the perfect situation. In other words, what is the probability of flipping a head on a coin? 1 out of what? 2. That's the mathematical probability. That's the Mayberry probability. What about flipping or rolling a 6 on a die? What's the probability of that? 1 out of 6. What's the probability of picking a king in a deck of cards? 4 out of 52. Those are all Mayberry probabilities. But if I was to bring in a deck of cards and you was to shuffle it 10 times, you pick a card, shuffle it. Put the card back in, write it down. Put the card back in, shuffle it. Put the card back in, shuffle it. 10 times, would you get the same fraction as 4 out of 52? No. Only if you're very, very coincidental and lucky. You're not going to get 4 out of 52. The physical probability is when you actually roll 10 times, or when you actually draw 10 times out of a deck of cards, or when you actually roll a die or flip a coin. You could flip a coin, and the large number rule, and that's what we call it, the large number rule is between these two guys. Now, I like to explain the large number rule. I ain't going to do that. I'm going to do this. Because I'm not doing math right now. I'm doing dang old English. So I'll just do this. Okay, there it is. Large number rule. The more attempts made, the closer you get to the mathematical probability. And the best way to explain that is by telling you the story. About 5 or 6 editions ago, we were using Triola, and Triola had one of those pages that tells a story about something in history. You ever seen one of those pages? And it told the story of these two math students that were in college, and they were in computer programming at the same time, and they took a roll of quarters, and they took that roll of quarters and they weighed each quarter, they measured each quarter with a micrometer, they tested the balance of each. I don't know how they did that, but they tested the balance, and they put all this information in a computer program, and they punched it in the computer. And they typed in, and they tested it. They typed in 10. And it said, if you flip a coin 10 times, how many times would it be tails? And they typed in 10. And then they flipped it 10 times. And they tested it. Well, they got it, what do you call it? They got it dialed in. They got the program to where it matched flipping the coin. They tried it 10 times. They put 10 in, and it matched. They typed in 5 or 50 times. They flipped it 50 times, it matched. And they found out through that computer program that it would take almost 100,000 flips for you to get the 1/2, the 0.5. Now, that's the large number rule. Now, why do you need this for probability and statistics? The large number rule dictates that if you are an executive with Michelin, you're the quality assurance engineer, director, whatever you want to call it, and you work over at the Crystal Palace over in Greenville, and you've got a meeting coming up in the next 6 months, and the meeting is going to be, you got to present on the Sandy Springs plant and the Anderson plant. You got to present the quality assurance of tires, going finished product tires, the finished product, and how many are bad or good or whatever. Because that means that they have to come back, and Michelin has to basically pay for it, because they have to take that tire, melt it down, do whatever, and make another tire. Just come on in whenever, that's fine. Hope lunch was good. Anyway, so you're a director with Michelin, and you work in the Crystal Palace over in Greenville, so you ain't making $17,000 a year. You're making more of $80,000 to $120,000 a year. Are you going to pick 10 tires? Or are you going to pick 1,000 tires? What are you going to pick? Why? And you get a less chance of getting fired. Why? Why are you going to get fired if you pick 10 tires? Because what's Michelin going to do if you pick 10 tires? They're going to invest their money into quality assurance based on what? 10 tires. Well, what does that do to you? Well, 10 tires is not enough. Okay? And your data is what? Accurate or inaccurate? Inaccurate. So Michelin has put in this money into quality assurance, blah, blah, blah. They've spent like $1 million. And at the end of the year, you still have defective tires. Why? Because your data was inaccurate. You should have went with 1,000 from Sandy Springs and 1,000 from Anderson, 1,000 from Sandy Springs. That way you had better, and then you could tell them, okay, this, and they would have to put, instead of $1 million, $1.5 million or $2 million or whatever the case may be. The point is, if you're putting your reputation and your neck, if you're doing a presentation on statistics or probability, should you go with the small number or should you go with the larger number that you can do? Yeah, you go with the larger number, and that's what the large number rule says. The the more attempts or the more people, the closer you're going to get to your goal. And the better your data is going to be. So don't be lazy and don't be cheap when it comes to, whenever you're given this. Because you have no idea. If I was to have told you that I was going to have to present to the president my first 7 years as a teacher, I would have laughed at you. But I had to, because I was department head at that time. And I had to present 7 years. Every year I had to make a presentation, a little notebook with graphs and photographs and everything. And I had to present, and I had to do the statistics. And you bet your bottom dollar I didn't pick just 1 or 2 classes. I picked 10 sections instead of 1 section. And I picked 50 sections instead of 5. Because I wanted my data to be correct. And that was just statistics. That wasn't probability. That was just statistics. So if I wanted to find out how many people were failing this college algebra, then I picked 10 sections of college algebra, and I used those numbers instead of just 2 sections of college algebra. So that's a very important rule right there. Not that it'll be on your test or anything, but whenever you're dealing with statistics, and you will deal with statistics in your profession. I don't care what your profession is. In order to plan and in order to predict, you have to have a good statistical perception of your job, whether it be deaths in a hospital or whether it be tires in a Michelin plant or TVs at an electronics plant or students in a classroom or patients that you're in care or that you're in charge of. Okay? Now, what's the other probability? Well, the other probability is called the physical probability. Now, I don't know what your book call it and really don't care. Because the only thing that matters to me is that you understand the difference between the two. This is the mathematical probability right here. Mathematical probability is based on what comes in the package. How many sides are there to a quarter? 2. How many sides are on a die? How many cards are in the deck of cards? They're based on the package. Where physical probability is based on how many times you do it. Physical probability is how many times you actually do it. Number of times, I can't spell today. Number of times done. And of course, this goes to that through the large number rule. So if I roll 10, I do a quarter 10 times. Heads, 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 tails, 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 heads, tails. That would be the physical probability. Now, of course, I came up with 50%. Very unlikely. If you take a coin out right now and flip it 50 times, I guarantee you 3 or 4 times it's going to end up the same. It's not going to be 2.5 times, 6 times. It's not going to be 3 and 3. Very unusual it would be that way. Okay? So that's the difference between physical probability and mathematical probability. Mathematical is based on the package, what it comes in. The die has 6 sides, so the probability of 6 is 1 out of 6. But you can roll the die 10 times, and I guarantee you that 6 is not going to come up as much as you think. That's why we have casinos. Because not all the time are you going to hit what the probability is supposed to be. If that was true, there would be no casinos. Okay? Now, the most important thing that you can do with these problems is not the math, but reading. You have to read. And I told you this last time before we went over chapter 4, or 4.1 and 4.2. You have to read the problem. Now, I'm not going to go through that again, but you can't just look over the problem and say, okay, that's 5 out of 10. It's just like the Shaq problem I told you. The Shaq and the LBJ problem. Any fool can tell you that Shaq is taller than LBJ or any president, but the relativity changes the whole problem. Same thing with or and and. In 5.2, the word is or. In 5.3, the word is and. And those 2 words make a question totally different from 5.1. If you don't look and you don't read, you're going to do a wrong problem when you know how to do it. You just do it wrong. Okay? So, you got to read the problem in 5.1. I gave you a couple of examples, and I'll give you a couple of more. And you don't have to do them, I just want you to write them down and think about them. One of the ones I told you before was the probability ruling. Rolling a 7 on a die. Well, you got to think. It's 0. Why? Because there's only 6 sides on the die. I put that question on test on 30 students, and I'll be 10 people missing. Because they don't read the question. And you got to read, and you got to think. There's no math involved. I mean, there's a little bit of math. If this probability of 6, you'd say, okay, 1 out of 6. That's all the math. But they don't read the question, and they don't think about the question. the probability of a even number on a die. Well, that would be 3 out of what? 6. Okay. Again, you have to think. The probability of a heart out of a deck of cards. 13 out of 52. Again, you have to know that there are 13 hearts in a deck of 52 cards. And if you don't know that, you pretty much what? Have to sit there and go, ace, 2, 3, 4, and put a 12 in there like I did. I mean, I don't know why I did that, but anyway. So the probability of a heart, never been able to draw a heart. Some of y'all can draw those pretty hearts. I never have been able to draw a heart. Is equal to 13 out of 52. And you can reduce it. I don't care about that. Okay. The probability of an even card. We did that the other day. I think last Tuesday or something. Okay. The probability of an even card. You have to think, okay, there's 4 suits. So whatever I get, I have to multiply by 2 or 4. 2, 4, 6, 8, 10. Jack, King, Queen. You said there was 8, right? But you got to remember there's 4 suits. So each one of those 8s, you got to multiply by 4. So 4 times 8 is what? 32 out of what? 52. Now see, the math is only 10%. 90% is thinking and reading the question. So in 4.1, I'm sorry, please check. In 5.1, 5.2, 5.3, and 5.5, which is 80% of your test, you're going to have to read the questions. Capiche? All right. So that's how you do the basic. That's 5.1. I'm going to try to cover a good bit today because it's not very difficult. It's just reading and doing a certain formula for each type question. 5.2. 5.2 should be the additive law. Somebody check to make sure you got to do it. Okay. The additive law is pretty much around the word or. I'm pretty sure it's the word or. Might check that for me. I think it's the word or. You see what is the probability of RH positive or O blood? Because that's one of the examples I'm going to show you in just a minute. It'll say probability of A or B. Anybody look it up? What page is 5.2?
247 it starts.
247. Look in there, and somewhere in there it's going to say the word or. It's going to say look out for the word or. Okay? Now the only other thing you have to worry about, I'm going to put this in red along with the or. Is always subtract the overlay. And this is something I came up with my first semester of teaching Math 120. Always subtract the overlay. You got some highlighters, you might want to get them out because we're going to use them. Now, most of your problems with the additive law are going to be in a table type form. Okay? And if not, you need to put them in a table type form. But one that I always give on a test or I always show in the classroom is the blood type. Thank you. I can't talk today either. I think I need some drugs or something. All right, so let's do one. Don't drugs help and stuff like that? It is on which one to take. All right, so RH negative, and I'm going to go ahead and give you the table, and RH positive. I'm just making this up. And the table will look like this. And I think there's, I don't know if there's 4 or not, I can't remember. But there's A, B, and O, and AB, right? Something like that. It doesn't matter, this could be sponges and buckets of water. I mean, it could be anything. And your numbers are right here. 2, 4, 3, 7, 5, 8, 1, and 1. Should make up something. Now, the first thing you need to do when you do any type of problem with probability is find the total. That's the first thing you do. So what's the total? Well, you add them all up. 5 and 3 is 8, and 2, that's 10, that's 21, 29, 31. Somebody check me. Y'all get 31? Yes. Thanks. Got 1 yes out of 12 students. Thank y'all. Thanks for the interaction. All right. So now what do? Well, the question, you read the question. Well, I want to know the probability. If I put people's blood types on a piece of paper and I put them in the hat, what is the probability of me picking a person with A type blood or with O type blood? So figure that. Anybody find the word or was it and? Anybody look in the book? I thought y'all were looking for it. I always get them, sometimes I get them mixed up. I think it's or. Thank you. What page is that on? Just so people know. 249. So the word or, you see it on page 249. Should have it in a little box or something. 249. Okay. So I take my handy dandy highlighter. And I make sure it's a big highlighter. And I'm going to use yellow for A and yellow for O. Is there an overlap? No. So you don't have to subtract anything. You just add, put it over the total. Here we go. Probability of A or O is all over 31. And 2 plus 4 is 8. 2 plus 4 is 8. I know I need to write it down. 2 plus 4 is 6. I'll just write 2 plus 4 right here. Plus, because we're using the additive law, 5 plus 8. Now, if I did have an overlap with the colors, what would I do? You would subtract it. And we'll do that in just a second. So 2 plus 4 is 8. 6 plus 5 plus 8, I have no idea. Thank you. Over 31. 8 is my terrible number. I can't add it to all. 6 plus 13 is 19 over. I can't do with 2 and 4 either. 3. And there's your probability. Turn it into whatever you want to. That's your probability of pulling an A type out of the hat or pulling an O type out of the hat. And that's how you do the additive. So, let's erase the highlights now. This ought to be good. I was hoping I could do it without messing up everything. Try this. Here we go. And now I'm going to find the probability of B or RH positive. All right, y'all do that, and I'll highlight it. We'll do one in dang old B and RH positive. Okay, do that one right quick. So the denominator is what? 31? And then I'm going to take 3 plus 7 plus 4 plus 7 plus 8. And I'm going to minus what? 7. What? Oh, and I'm going to minus what? 7. Because the 7 is the what? The overlap of the colors. And if you use highlighters on these problems, you will never miss it. Now, a lot of people, why don't you just cancel out with that? Well, that's the people who know how to do it. That's not my job. My job is to teach people who've never seen it before. Okay? The overlap of the blue and the yellow and the green. And 3 plus 7, and I'll highlight that. Hold on. Let's see, highlight the green here. I do so much for y'all. I hope y'all appreciate it. Maybe not. Just be quiet. All right, so here's the red. I'll color that red, and I'll just put this. And 3 plus 7 is 10. You can take the 7s out right here if you want to. You can cancel them out, or you can cancel this one out. You want to cancel one out because there's only one here. So you could do that if you wanted to, or you could just add it and subtract it. I don't care which way you do it, it's fine. So let's take the blue marker, and I'll take this one out without it. And then we get 3 plus 7 is 10. 8 plus 4 is 12. 23 over 31. Somebody check me. And that's your answer. Now, of course, 23 over 31, if you can reduce the fraction, reduce it, or turn it into a decimal. But it should be between 0 and 1, because that's probability. And that's how you do the additive law. It's real simple. Now, the only problem is sometimes they don't give you the table. Sometimes you have to, and they'll give you ages like 18 to 21, 22 to 24, and they'll tell you, and you have to put it in the table, and then after that, it's just real simple. Okay? I want to try to get to the multiplicative law, and we'll do a couple of problems with the multiplicative law. And that way you can work on 5.1, 5.2, and 5.3 in one little group. So, the multiplicative law. Again, it has two things that you need to remember. And that's 5.2. 5.2 is the multiplicative law. That's supposed to be an L. Multiplicative law. Mut law. 5.3, I'm sorry. You're right. I've got used to it being in chapter 5 for one thing. It used to be 4.3. 4. But anyway, 5.3 is multiplicative law, and this focuses around the word and. What is the probability of A and D. And this also focuses around width, replacement, and you need to look in your book. Or without replacement. Now the book, this is real simple if you think of replacement and without replacement. But we have to do something to confuse you. So the book tells you independent or dependent. I always get mixed up. I don't even look at that. Which one affects the probability of the next one being picked? Well, think of marbles. A bag of marbles. And here's your bag of marbles. And we got 4 black marbles. We got 3 green marbles, or red marbles. We got 4 blue marbles. And we got 8 green marbles. Now, what's the probability of me picking a red marble? Well, first you got to total them up. 4 and 4 is 8, 8, 16. I done lost count. 19? Okay, you got 19. So anything you do is going to be over 19. Now, what's the probability of me picking a red marble? That would be what? But what if I kept it? It would be 2 out of 18. And what if I kept that one in my pocket? It'd be 1 out of what? 17. That, without replacement, affects the what? I don't know which one, y'all English people, I don't know. I think it's E when it's actually like an action, I don't know. Affects the outcome, affects the probability for the next one being picked. Now, look in your book, and I think I can't remember which one it is. It's either dependent or independent that affects the probability. So somebody look in your book and find it, and we'll write it on there. Okay? With replacement does not affect. Okay? So what do you have to remember with these problems? One, if it's and, it's multiplicative law. And you have to discern whether it's with replacement or without replacement. Will the question tell you? Yes. There's no way you know unless you were told. Now, after 3 or 4 digits, after you get into the 3 or 400s, it doesn't matter. Like, there's 1,027 CDs in a box. How can you tell if there was 500 that are good, or 1,027 if there's 785 that are good? What is the chance of picking 3 CDs that are good? Well, that would be 7. It wouldn't matter if you used with replacement or without replacement, because your 2 numbers are above 200 or 300. Anything above 200 or 300, when you start dealing with those type numbers, it's not going to matter, and we're going to do a problem. It's not going to matter if you with or without replacement. Yes, ma'am.
It's on page 259, independent.
Which one is effective?
Experiment does not affect the probability of the event if it's independent.
Okay, so the dependent is the one that without replacement. So you need to put dependent here. Is that right? And independent here. Always remember the marbles. And that's how you keep it straight. What's he saying? Huh? Independent does not affect. Okay? And if you think about it, think of your deck of cards. If you was to pick a card, some people tell you to hold the card, some people tell you to put it back in the deck. If you hold the card, you're affecting the probability for the next pick. Make sense? Okay, this means yes, and this means no. Okay. 3 or 4 of y'all did it. Thank you for the interaction. So let's try one. Let's say we're going to pick, let's say we have a deck of cards, and I want to know the probability. I don't want to write the head unless it's important. Probability of picking a king and a queen. Oh, that's fatal. Oh, what's wrong with today? Okay? Find the probability of picking a king and a queen. Now, I have told you the second most important part. With or without replacement. With replacement. So in other words, I'm going to put the card back in the deck. In fact, do it both. With and without replacement. And you'll see the difference. Because are these numbers over 200? No. So you're going to see a difference between this one and this number. Mathematically. Somebody tell me what the denominator here is going to be. What's this one going to be? 52. Okay? And there's what? How many kings are there in a, 4? And there's 4 in, and I multiply it. Well, I can do that, or I can say 4 over 52 raised to the what? Second power. With replacement, you can just do this. Okay? And that'll be 16 over some BA number. Somebody tell me what the probability comes out to be. Huh?
169.
Give me the decimal, if you don't mind.
0.005.
Okay, 0.005. Is that right? 59 or whatever, I don't care. Is that verse 3? Now, let's do the other one. Well, the other one, you got to be careful because if you're picking one king, then the other one's going to be not out of, if you pick one out of there, you're not going to pick the other out of 52, you're going to pick it out of what? Times 4 out of 51. And that's going to give you a different number. And it'll come out with a different number. The best example I give you, and the one that you're going to be tested on, the one that you're probably going to see in your homework and test, is the CD problem. Let me show you what it looks like. And I'll just type it out because you're going to see it again. Hint, hint. They call it something sampling. I can't remember what it's called. Assurance sampling is what they call it. A CD factory or whatever has made a box of CDs. Total is 1,127. Okay, that's the total in the box. Assurance sampling basically, and I've spelled that wrong, is picking all good CDs in a sample. the employee needs to pick 5 times. What is the probability of picking 5 CDs together? In other words, to make this without having to type all this, you got a CD company. They don't make the CDs that have music on them. They make the blank CDs that you record on. All right? They make a big old batch, and there's 1,000 in a box. You, as a quality assurance person, says, I need to check this box before you send it to Walmart or Target or whatever. And they go through and they pick 5 CDs. They go back to the lab, they test the CDs to see if they're good. If they're all good, then that box goes to Walmart or Target, and then let them deal with the defective ones. And that's how they usually deal with them. In Target, if you got a bad CD, you take it back, and they'll just say, go get you another one. And they send the ones back to the factory. If one of those 5 CDs are picked and it's bad, then what does the company do? Do they send it to Walmart and Target? No. They go back to wherever they were made in the factory, and they see what's wrong. They find out what's wrong. Because if one of those CDs are bad, out of the 5 or the 3 or the 7, whichever they decide to pick, then they're sending out a liability with that case. You see what I'm saying? And that's what this question's asking. So they want to know, what is the probability of picking 5 good CDs in a row? So, now, it doesn't say with or without replacement, but it's usually without replacement. Because once you pick a CD, you don't want to put it back in. And in this case, the application does not warrant you putting it back in. Because what are you going to do with the CD after you pick it? You're going to test it. So it'd be senseless to pick it and put it back in. It's kind of like voting and dead bodies. You can only count a dead body one time. You can only count a vote one time. So if you have a voting or a dead body problem, or one of these problems where you're testing something, it would be non-beneficial in the context of the question to put it back in the group. Okay? So again, reading and thinking tells you the answer. So what do? Well, you get a total. Well, I usually tell students, draw a box. Oh, they also, quality assurance, they also tell you one more thing. They tell you that 227 by quality assurance in the past, 227 are bad. They tell you that. They have to tell you that. I'm sorry. Today is just not my day for working on the computer. Comma, 227 are bad. A lot of people say, well, how do they know that? Well, because quality assurance, what is their job? Say again? Yeah, see what's going to mess up and why stuff is messing up and why this batch of CDs is bad and all that good stuff. They're kind of the monitors for the product going out and making sure that you're not putting something in there or something's wrong with one of the machines or something like that. So they have a percentage. So when they look at that box with 1127, they punch in their calculator, well, the pass is 10%. So 10% or whatever it comes out to be, they say right before they even stick their hand in it, they know that 227 are probably bad. Okay, now what does that do to the problem? Well, up here you got 1127 as the what? Total. So over here I'm going to put a corner here and I'm going to put a corner here and I'm going to put good and I'm going to put bad. Now the question says we know that what? 227 are bad. Therefore, wait a minute. Therefore, if 227 are bad, how many are good? No, that's what I heard. 900? I love how y'all can take something as simple as 900 and turn it into a number. Okay, now the question's asking you, what is the probability of picking 5 good CDs in a row? Well, you can take the 900 with replacement. That would be 900 over what? Over 1127, Hubert. Thank you, class. Raised to the what? Can everybody say fifth?
Fifth.
Let's say it all together. 1, 2, 3. Fifth. Not.
Got it.
Fifth. Without replacement. Y'all do that one because I'm not going to write with this thing. I'm going to have to get up and write. I don't want to write with it. Without replacement, write it out because you got 5 different fractions you got to write out. Somebody tell me what the first fraction is going to be right here. 900 over what? 11.
27.
Thank you. That was enunciated. Times what? 899 over 1126. And you keep breaking it down until you get 5. This is your first pick. This is your second pick. This is your third pick. 898 over 1125. 897 over 1124. And the last one is 896 over 1123. Good. Now somebody be calculating this, and I want 5 digits. Somebody give me 5 digits on this. Point. 1, 2, 3, 4, 5. It's not that hard to do. I'll do it. Got people scared to calculate and scared to talk. It's a conspiracy. And y'all know whose fault it is. Whose fault is it? Bush's fault. Bush caused all them people to get killed down in Florida. It's all the guns' fault. We shouldn't have guns. Guns kill people. People don't kill people. Guns kill people. I'm being very sarcastic if you hadn't picked up on it yet. All right. So parentheses, 900. Don't try to answer it now. 900 divided by 1127. It's like after you take the time to go get the thing sweep with the broom and the dust, and you mop up before somebody going, you need any help? After you already cleaned it up. All right, 1127, and then you raise it to the what? To the 5th power. 3, 2, 4, 7, 8. 3, 2, 4, 7, 8. All right, somebody do the bottom one. I'm not doing that one. I want you to do it because there's a reason I want you to do it. 5 digits. Hold on, let me make my little 1, 2, 3, 4, 5. What is it? 3, 2, 4, 0. 4, 0. Okay, well, 3 digits doesn't matter. And 5. Well, you can see, does it make that big of a difference? No. And on the homework and the test, they give you, I think, the 10 or 100 thousandths variance. In other words, above or below 100,000. So you could put in 0.325, you could put in 0.324, and you could put in 0.320. Either one of those is correct because they give you that variance because of different calculators and different rounding. But that is a test question, if not a homework question. In fact, I'll go pull one up and see if I can find one for you because I didn't write it like it's supposed to be written. So we'll do another one together. Let me pull up my handy dandy homework. That's not it. That's not it. There we go. And this is 5.3. Let's see if I can find one. Must be in the first few. I must have changed the questions. These are all simple questions. Well, I'll find one. It's probably on the test. Give me a second. Let's test this unit 2. Be in here somewhere. I had to pull the only test that we can put it up there. I'm just ready to quit. I'll find, don't worry, the easiest way to find it, I'll Google it, dadgummit. I just want you to see the wording. I think it's assurance, sampling, CD.
Some of them sounded pretty rough. Some of them sounded good, but some of them
Oh, what that is. What are y'all talking about?
at Wild Wings they have karaoke night, and they're like, some of the people that don't sound good shouldn't be on stage.
What night is that?
Tuesdays.
Come up there and sing some dang old George Strait. You'd be surprised. Yep. I can do some outlaw country, some real country, and I can't do that crap they play now, but okay, I can't find it. Y'all just trust me, you're gonna see it again. I don't know where you're gonna see it, but you're gonna see it again. Let me get to a question in the book. Maybe it's in the book. This is 5.3, right? Yeah. Let me find one in the book before y'all leave today. A couple. All right, here's an example of a problem. Let me pull it up where you can see it. Okay, it's at the bottom down there. Let me blow it up a little bit more. In a game of roulette, the wheel has numbered slots 0 through 000, and 1 through 36. A metal ball rolls around, blah, blah, blah. What is the probability that the ball will land on a numbered 17 2 times in a row? Now be careful here, because you might be thinking, you know, there's one slot, there's 2 slots, and then how many are right here? So how many slots are there total? 38. The trick on this one, people will put 36. They forget about 0 and 00. And if you, again, you don't read it and you don't think about it, you're going to put 36. So don't do that. 38. Now, can you take the 17 off the roulette table after you hit it? No. So are you going to with replacement or without replacement? It's with replacement. The 17 stays on the wheel. Context, reading, thinking. The math is not hard at all. Yeah, some people get up there and karaoke, and you have to go outside and take a fresh air break.
That'd be me. If I was up on stage.
You don't know
I
that.
have fun though, you know, that's the main thing.
Well, after about 3 or 4 beers, you know. I'll be the first one up there. I don't have to be drunk at all.
We, Carnival Cruise Line has like a karaoke room, and then we get packed out. Hold on, I swear I went like 4 times, and my family did the same.
I could sing at karaoke like all night.
Really?
Mm-hmm. I love it.
Are you good?
Mm-hmm. I'm making a lot of noise. I got George Strait nailed down pretty good though. All right, so what do? Well, 17 over what? 38 and times 17 over 38, or 17 raised to the what? 17 over 38 raised to the what? Second power. Oh, I'm sorry, 1. I'm sorry. My bad. 1 number. I was thinking of 17. There's 1 17 on the whole thing. That's another thing you do. You get the numbers mixed up with the math. All right? I said 17. Well, you could. No, you can't. The number 17 is not mathematical in this problem, is it? It's the block that the 17 in. How many blocks have 17 in it? 1. So 1 out of 36, that's what it's asking. I'm sorry. My mess up. That's very common to put 17 up there. I just did it. Now that's the problem. And you could do 1 over 38 raised to the second power if you wanted to. I'm trying to find one like the, I don't think this is one. Let's see. Probability that a randomly selected male will survive the year. No, I don't like that one. That's a very confusing problem. People hate that problem. The insurance problem. Make sure you read this on page 262. It's just a do-over of some of the material we've done. I'd like to find that CD question. Usually talks about quality assurance. There's quality control. Suppose that a company selects 2 people who work independently expecting 2x4 timbers. Their job is to identify low quality timbers. Suppose that the probability that an inspector does not identify low quality is 0.2. That's kind of backwards from what I was wanting. I guess they retired the CD question. All right, let's find another one. Let me go back to the homework because they have the answer, and that way we can check the answer. All right, I don't know what this one says, but among, I can't try to blow it up for you. Among 49 to 52-year-olds, 32% say they have driven a car under the influence of peer pressure. I guess, I don't. Oh, under the influence. Well, that could be read 2 different ways, couldn't it? It's under the influence of peer pressure. What's under the influence of peer pressure? Or it could be written as under the influence due to peer pressure. They need to check their writing. Suppose, I guess they're talking about drunk. Be peer. The question's not written right. Again, you got to read. Suppose 49 to 54-year-old are selected at random. What is the probability that at least one has not driven a car while under the influence? What is the probability that at least one has driven a car? What does at least one mean? Well, let's do a number line. Because this is where you got to think. The math here is not hard. You got to think. So let's take our handy dandy clear board. Go away. And let's just draw a number line on this book. I'm just giving you something to think about. Yeah, everybody did good. I think it was around 80, 85. Had a couple of zeros. Yeah. All right, so here is 1, 2, 3, 4, 5, 6, 7, 8. I'm just marking it up. And let's say this is 0 because you can't have negative 1 people. So 1, 2, 3. I'm just drawing this so you can think. 4, 5, 6, 7, 8. At least 1. That means the lowest number is what? 1. So that means it could be any, at least 1. Let's see, numbers right here, right? At least 1 means that the lowest number is what? 1. So what's the only number on this number line? It can go up to 9,900. What's the only number that's not represented? Now, there's a thing in probability called the complement. Okay? And the complement tells you there's a way that you can use the complement to help you out. Did an I or E? Complement. Now, a lot of you say, if I ask you what a compliment is, some of you are going to say, you have nice hair, you have a nice dress, you have a nice pair of shoes. No, not that compliment. That's not a mathematical compliment. But you can think of a compliment as behind every man is a good what? Okay, the old saying. Okay, now some of y'all might take offense to that. I don't care. All right, it's an old saying. I didn't make it up. Behind every man is a good woman. That's the compliment. Because in marriage, two people are supposed to become what? A whole. Okay, so the marriage is a whole. And the complement to the woman is the man. The complement of man is the woman. The complement of true is false. The complement of false is true. The complement of 0 is 1. Now, and I always give this example because you have to think of it as a whole. When I was in junior high school, my mom and dad would give me $1 each day for lunch. Okay? Lunch was 65 cents. Okay? I always remembered I'd get 35 cents. So this day, I can do that math in my head real quick because I went 3 years, I cannot tell you what high school lunch cost, but I can tell you what junior high cost because they give me $1 and I'd get 35 cents back. And I'd have a quarter for the ice cream truck, whatever, at Southwood. Now what's that? 35 cents is a complement to 65 cents because both of them make up what? The whole, which is $1. Now, you can have a complement also with a percentage. If the percent is 100%, then 35% would be a complement of 65%. Well, what about a total number of people in the classroom? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 people in the room. 3 have big heads. Okay? That means 7 have smaller heads. Okay? 3 are blonde. That means 7 are not blonde. 3 are women. That means 7 are not women. See what I'm getting at? All right. So, the complement here of at least 1 is what? 0. Now, can you use that? Yes. You can do the probability of 0 and take that away from what? The whole, which is 1. Because what does probability go to? 0 to 1, Hubert. That's right.
Yes.
Thank you. So the probability of all these, and you can have it in 9,900, the probability of all these things happening is equal to 1. Or if you want to think of it as percent, 100%, or 1. So if I want to know the number of people there, and I don't have any clue how many there are, then what do I subtract from 1? Probability of 0 is what happens. Okay? Now, that's what a complement is. Now, when do you start seeing complements? You start seeing it with these type problems right here. Okay? So, it says, what is the probability that at least 1 has not driven while under the influence? Let me reread that. What is the probability that at least 1 has not driven drunk due to peer pressure? First of all, you got to establish it says 32% say that they have driven a car. So what does that mean?
Just take out 100%.
And what would that be? That's the complement. What would the complement of 32 be? 68%. Y'all don't work too hard on the calculator with that. So write that down. 32% say they have driven a car drunk because of peer pressure. and 68% have what? Not. Okay? I'm looking, suppose 2. Okay, there you are. There's your other number, 2. Suppose 2 numbers are selected at random. So you could actually put 49 to 54 years old, and you could put, well, I'm just thinking out loud. 2 people are going to be picked. It says, what is the probability that at least one has not driven a car under the influence of peer pressure? And then B, what is the probability that at least one has driven a car drunk under peer pressure? So take a minute and work on that. I need to call the roll while y'all are working on that too. And if you can't do it, like I say, just chalk it up as what? Failure. Yeah. Y'all are learning. Pause the video right quick. I don't want anybody to see the attendance. Do.